Welcome back, everyone. And today is going to be a special video because this one is viewer requested. This one's for you, Jiro G. He wanted to know when we're going to start doing some wireframe shader and Barycentric coordinates. I started messing with Barycentric coordinates a little bit, like in a way, when I started doing the low poly shader. But this one we're going to really do. You're going to use it the way how it is for wireframing. And a great tutorial, especially if you look up online, by Florian, I can't pronounce his last name, really gives you a good example and overview of how it all works to get it done with the wireframe. The big problem is there's no way to actually draw a wireframe in WebGL. I think OpenGL does have a mode or a drawing mode for it, but WebGL does not at all have it. So you have to do some tricks to get it to work. The cinch of it is that the entire model has to be broken down to triangle faces. So that means you have to duplicate vertices because you need to every single triangle needs to be defined. Once you have every single triangle defined in your entire model, then you apply special coordinates to each point of the triangle. This allows you to, when done with interpolation, is that if any one of these components, X, Y, Z, gets closer to 0, that means you're closer to an edge. So basically, it's kind of a way for edge detection. So again, it's really just using interpolation to find the closest component to 0. The closer to 0 you are, the closer to an edge you are. If you're like right here in the middle, every single component is going to interpolate to like 0.5, 0.5, 0.5. And it'll get smaller and smaller, basically, in every direction it goes. Like one component will get bigger because it's always going to go between 0 and 1. So like I said, the closer to the edge you get, the closer to 0 you are. And that's really it is you're just triangulating. It's kind of like having radio towers and GPS, and it triangulates where you currently are, and it can tell you if you're closer to a tower or not. And when I'm saying I meant the pixel. So you have to do this in the fragment shader. So you have to do it per pixel. So here's a nice illustration about it. So there we go. So to get this to work, we could do some changes to the core. So let's start off with some core changes. Now, one of the things we need to do is we need a new blending feature to be enabled. We have blending state, which kind of allows us to turn on and off alpha, but we need this one to get this to work right. It took me a while to figure out how to get this running just right because I was missing this blending feature. This feature, once we get to a lot of line of code, I have the full name right now. Sample alpha convergence. We'll see. But this feature, or this mode, or this setting, allows you to still use Z depth testing, or depth testing in general, and it just blends the color. So if you put in a color in there, it'll kind of just blend it in. So this way you could kind of do like a 80% transparency, and you see that the front color kind of overblends with the back color, and vice versa. The colors blend together, because one thing I was noticing is that without this mode turned on, the Z buffering would replace a pixel. So if the back things were being drawn last, basically the Z testing would get in the way of actually blending it together. So if I drew the back and then the front, it would blend. But if I did the back then the front, it would not blend. The front would actually override everything was drawn in the back. It just kind of just replaces the pixel and applies the alpha to it. What this does, it blends the two colors together. So hopefully I explained this mode correctly. So we need to actually have this mode controllable in Fungi. So this is our global state, because remember, we're keeping global state, so this way we can turn it off based on the the object that we're trying to currently render. So let's see. If we're here, what's the next line of code? So this is at the top of fungi. Scroll next down here in materials. Materials is really good. We're just going to control it, and there's the name, the sample alpha coverage. So in materials, we're going to add a new state controller. Basically, it's kind of a setting. So so when we're rendering with the shader, we're saying, okay, we want this mode on while we're using the shader because we need that special blending mode turned on. So that's in materials. What's next? And then inside our render, remember our render thing at pretty much near the end of our fungi, and in our prepare next function, we're just testing to see is the setting different from the global state. If it's different from the global state, no, we just turn it on and off. And that's what's called sample alpha to coverage. So that's just those 3 lines of code allows us to control that blending state in our rendering. It's pretty cool. It's a really nice feature. It's nice to know. So now we can blend colors a lot better. And this only blends when you're rendering during this one rendering. Because the other you don't need it when you're drawing on top of things. I guess you'd kind of still do. I don't know. I haven't really tested it. But overall, if you're having like colors not blending correctly, this is probably the feature you need to turn on to get that effect, the effects you're looking for. So like once you have this feature turned on, you don't need this blending turned on. So this is one type of mode and this is a different mode, basically. Let's see. So we're now going to primitives, and we're going to fix our polar sphere because we're going to use our sphere function to render today. And one of the things is that we don't need the VEO setup, but I still need the geometry of the sphere. So one of the new things we added into, we're actually going to pass in the array vert and array index, and if they are not undefined, that means we only want the geometry information. We don't want to push this to the GPU at all. So we just want the data of how the sphere exists in 3D space. So we're just checking to see if it's geo. And right here, in the event that we're using the old code, if we just want to quickly create the mesh as soon as we're done creating the data, we just generate an array that exists only inside this scope. Actually, no, it won't exist in this scope, because everything's in reference. So, but either way, well, actually, it might be in not reference because it's not referenced outside the function. So, yeah, JavaScript and referencing is very tricky. You gotta keep your head in the game with that. So, like originally, where I had it predefined within the scope of this function, I'm kind of now defining it. So if it's undefined, that means I kind of just want the at the end I want the VAO. Else it doesn't return anything. It just fills in the arrays with data, and then you do things with it. So everything pretty much stays the same except for this. This replaces that, and then we have an if statement to check if it's geo. So if you're passing in these arrays, that means we're not going to create a mesh at all. We're just creating geometry information. This is starting to show me why 3.js has a geometry class. I'm like, why do I need a geometry class? And now I'm starting to understand it, because what happens if you just want the geometry information but you don't want the mesh yet? Because maybe you want to process that information before you generate a mesh from it. Or in our case, we're using that as a starting point, which we're going to recreate it in a different way. So now that we're done dealing with primitives, now we're going to go to our test page. So one of the first things we're going to do is we're going to create a new shader. We're giving it the name wireframe. We're going to it's going to be inline. It's going to be called vertex wireframe and fragment wireframe. Everything's pretty much the same. We want culling turned off. So this way we can see, because we're going to see through our wireframe to see the back. So we need culling turned off. and then we turn on a new blending mode. Like I said, I'm not turning on the other use blending. So this sample alpha coverage is the blending mode we really need. And I'm defining it to triangles because we need to do triangles. So now we're going to start creating our mesh. So here we're defining 3 arrays. This is our verts and this is our index. And we're going to pass it into the polar sphere, which creates geometry. So we're not going to get back a VAO. Now we're going to have a new function called triangulate triangle strips, which basically you pass in all your triangle strip information, the vertices and the indexes, and it's going to triangulate every single triangle in our mesh code, or mesh data. So we're not going to make a triangle strip. Like right now, it is as triangle strip information, but now we're going to take triangle strip information and convert it into triangle information. So it's going to duplicate all the vertices that it's required to make every single triangle face its own definition. And once we have our triangle, then we're going to just create our mesh from it. So we're going to pass it in, and it's a component of 4 because our triangulate tri-strip does something different. And everything is pretty much the same. We're not passing index, we're passing nothing. It's just pure vertices that we're passing in, and we want a VAO out of it. We create a renderable that uses our wireframe mesh, and we push our model. That's it. So over here, we're creating our geometry information and then converting it into pure triangle information. And that's it. So now we're going to have to deal with our triangulate triangle strip. Now, normally, a lot of tutorials, when they do this and when they teach you about like triangulating, these components, or these extra 3 arrays, or these extra vec3s are applied in another buffer. So you have to create a different buffer, and then you have to save these per vertice. So every time you make a triangle, you have to save an additional 3 floats of information. Since we have full control of our shader and the way we do our code, we're going to go back to using the W component to actually save which corner of the triangle we're in. So instead of saving this bit information, we're going to say that's 0, that's 1, and that's 2. And we're going to save that in the W component. So in our shader, we're not going to pass in X, Y, and Z. We're going to pass in X, Y, Z, and W. And that W component would then identify each corner. And then the shader would then define these in the vertex shader, convert the corner index to the actual barycentric component, coordinate, sorry. So we've done this before where we set the color per vertice, and the color is defined as an array in our shader. So the idea is that we're not creating another buffer, and we're not saving a bunch of extra information into the GPU. So this way we're kind of optimizing everything. So since we have full control, why not be very nice about it? So here's the loop that I created that can turn pretty much any triangle strip into triangle information. It tests to see if it's a degenerate triangle, so it skips that because that's bad information. As you can see, when we create what do you call them? Triangle strips, it's kind of like a backwards end pattern. You go down, up, across, down. So, but to triangulate, we need to kind of change everything into quads. So we know what the 4 points are. We just kind of reorder them so that they're quads again. So that's why 3 and 2 are swapped, because I'm kind of swapping them around, and that creates our quads. So we're converting them to quads. And then we calculate, and then this loop, it kind of just converts this our quad into triangles, and as it's creating the triangles, it's just defining the point, the corner point. So like I said, the top of the triangle will be 0, the next one will be 1, and the next one will be 2, and that will get saved in the fourth component. So as you can see, here's here's X, here's Y, here's Z, and BI is W. So that's what all this is doing. It's just converting our quad into 2 separate triangles. And that's all it takes really to triangulate. Now, it's not too much work to triangulate the triangle strips. Now we're going to go into our shader. So here's our wireframe shader. What happened? There it is. So all we really need is our position. We're not using normals, UVs, especially for wireframes. We don't really need any of that information. Still need that. We still want our model matrix in case we want to do it. And we're going to have a vec3 out, which is our Bary coordinate. And here, as you can see, we're going to check to see our W component. If it's 0, it's that coordinate. If it's 1, it's that coordinate, else it's that. The end. So we're not saving all this information in the buffer. We're just saving, we just have a single buffer, a single vector object to deal with, and it just, I guess to me, it's just easier. We put more work into the shader instead of wasting a lot of memory. And then we have our fragment shader. Our fragment shader, very simple. We kind of bring this in. We have our out color. Here's a function called edge factor. It basically just defines the edge. There's one way of defining an edge, basically. This, I'll talk more about it later because we're not going to use it right off the bat. Then we have some information. Some of this information really exists for the third example. But it's basically, in the future, this will be basically uniform, so you can define it. Of course, my phone calls right now. Oh boy, I love that when that happens. I can't turn off my phone right now. I can't believe it. My phone is on right now. All right. Okay. Oh, Summer really wants to talk to me today. Oh boy. All right, that's off. All right. Sorry about that. Sorry for the interruption. Too bad I can't edit that out. All right. So, because I'm lazy, I don't feel like editing videos anymore. So here we are. So we're going to define these are uniforms in the future, but for now they're just constants because we're prototyping. We don't need to go through all that hassle. So this defines the width, like how thick we want the width to be. Feathering is the anti-alias, because if we don't define like a feathering, like a spacing between the first color and second color, the lines is kind of jagged. So basically we're just doing anti-aliasing with feathering. And then we just define the colors of our 2 faces. So the lines is going to be black, and then our face is going to be this kind of dark gray with 80% opacity. So it's kind of transparent a little bit. And then at the very end, we have a simple thing. We check our Bary coordinate that's been interpolated. If any component in that thing is less than 0.1, we're drawing a line. Else, we're drawing the face. It's that simple. Like I said, the closer you get to 0, the closer you are to an edge, because basically barycentric coordinates is kind of a way to find to do edge detection on a triangle. And with that all set up and good, this is what we get. We get our wireframe model. And see how the blending works? Like the back is kind of like it's like blended in with, or averaged out with, the face color that's in the front. Let's see, what is it? I forget what it looks like if I have that feature turned off. So this way you can see what that mode really does. Refresh. I'll make it solid. Right? But if I turn on the other one, mat.use blending equals true. Oh, damn it. I hate when that happens. So many errors right now. All right, not errors, but save. Refresh. See how the drawing is done? The blending, it's more like the face is overriding the back. So sometimes it works and sometimes it doesn't. It depends on the order of operations of when everything's being written. So the back part, like right here, is probably being drawn first, and then the face is drawn second. So it overrides it. Even though blending allows alpha to work, so it alphas the existing frame buffer, it does not alpha the current drawing that's happening. So like that's probably like this line of here that's transparent is probably being drawn second. So the face is drawn, then that line is drawn on top of it. So it's using alpha blending. So that's why we need not this blending, we need that sample alpha coverage. That is what gives us that perfect blending. It blends no matter, it basically blends no matter what the order of drawing is. So that's the beauty of that. Now, let's see if we can zoom in. Now, we're not using feathering. So as you can see, whoa, the lines are kind of jaggedy. So you can improve that by using feathering. So scroll back down. Now we can use that function that that tutorial, that page I showed you was using, the edge factor. And the beautiful thing about this edge factor function, let's see where it is. Oh, sorry, it's right here. F-width does df dx and df dy on the coordinate. It's kind of like a derivative. I don't know how derivatives work in GL. I kind of know what the idea of derivatives are, but I'm not really good at that math. So it kind of helps you define a width in a way. But the way this edge function works, like I said, I'm not a mathematician, so I can't really understand how the most of it, but I know what it does. What this does is it defines a width that you can draw on the line, but it always stays like that no matter how much zoomed you are. Because right here, if we're zoomed in and we can see that this line is huge, it's very thick. It's realistic. The wireframe is realistic. So as you know, it's kind of like basically just like a window frame. So the closer you get, the thicker that line gets. But if we use edge factor, that's not the case. The effect is different. So if we get that out and use that, we use edge factor, refresh. Now, as you can see, as I zoom in, the lines always stay the same. Ooh. And they're a little thick, they're very thin. I think you can change the thickness by using that, by multiplying that value. Refresh. So yes. So, but by changing that, you also change the feathering in a way. I think if I go even higher, let's see, let's try like 8. There you go. Then you can kind of see the feathering a lot better. Kind of hard to see. It's there. That little slight like gradient or blurring on the edges. So that adds a little feathering to it. So this way, no matter how zoom far away you are, the lines are always the same. So it depends on the effect you're looking at. Like having a really thick lines like that kind of sucks when you're zooming out. So if you want nice thin lines, this is what that tutorial uses. And now you can do, the final example is what I did as I bashed my head into the wall trying to come up with something without, so basically it follows the same idea as the original one. And it kind of uses the mix of the two ideas together. The only difference is it creates a line with a little bit of feathering that uses these two values. And it changes based on zoom. So if I save, refresh, so you can also when you zoom in, so the lines will get bigger, but there's kind of an anti-aliasing happening on the edges. So this way we can kind of get away with that. So now you're inside, and and that's it. And there's our wireframe. And when I have a little bit more fun, let me go back up. No more shaders. So, all right, our polar sphere. Let's do 10 on our horizontal and 15 rows. I forgot what that number is. Oh, that's a radius. And we do a refresh. Boom. There is our wireframe sphere. Beautiful. You can see the inside. It's pretty cool looking. Yeah, there we go. So here's wireframes and barycentric coordinates. So now you guys can do wireframe. That's the thing that only sucks about it, is that you have to triangulate the mesh. Depending on the mesh you're dealing with, you might have to write a new triangulation function. But most often, if you're loading in a file like an object file, in one of our previous lessons, we loaded up an object file. All the faces are defined. So you can. So while you're uploading, when you're loading it in, you can just save all that data. You just create the vertice array based on the data that's coming in from the object file, and so you don't have to triangulate at all. All the triangles are there. So all you have to do is that where the mesh might not duplicate, because I remember the way we set up, so this way we can prevent duplication. Just load it up, and you make sure you duplicate every single face. If every face that's defined, that's the data you reuse, and you create our vertice array from that. So this way, like I said, you don't have to triangulate. All the triangles are technically there, and sometimes our object file is in quads. All the quads can always be broken down to triangles very easily. It's that 0, 1, 2, 2, 3, 0 pattern. That pattern pretty much works out for any quad that you have set up. Usually, I never had a problem with it. So that's the only tricky thing about wireframes, is that you have to triangulate all the data into triangles, and then from that point you can then draw the triangles independently, which then kind of forms up this mesh. So hopefully this works out for you for 0G. Hope you like it. Hopefully you got the information you wanted, and at least some source code and how to do it in WebGL. And I did it a little differently. Like I said, instead of using buffers and stuff. Like I said, you can use buffers if you want to duplicate the data per vertice, or if while you triangulate, like I said, you just define each corner and then have the shader kind of put in those barometric coordinates for you while it's interpolating, while it's drawing. Like I said, it might give you a slight less performance, but you probably won't notice it at all unless you have like hundreds of objects on a screen and each one is triangulated. Like I said, the more vertices you have, the more it slightly takes longer to render. But this thing is working pretty good at 30 frames per second. That's pretty typical for WebGL. So I can just do crazy things and my frame rate's still at 30%. So yeah, you won't like I said, you probably won't even notice it based on the model you're dealing with. The last thing I just want to say is thank you to Michael. I don't want to say your last name just in case you want to kind of stay anonymous, but I want to say thank you, Michael, for being my first Patreon. I have Patreon set up for like over a year, mostly when I was doing a lot of free 3D modeling for 3D printing things. But no one ever, gave me any cash or whatever. And I have never mentioned Patreon during any of the videos because I really don't want to beg for money. But I just want to say thank you to Michael because he is my first Patreon that kind of came and just gave me $1, and that's great. Even 50 cents, even a penny, I don't care. It's great. I don't want to beg for anything. So if you guys want to, that's great. But I'm really not going to sit there and remind people during the videos, hey, give me some money for Patreon. In case you're wondering why I have a Patreon, I set it up a long time ago for because I was doing, like I said, I was doing 3D modeling on Thingiverse. Everything that I have under Sketchpunk Labs and Thingiverse is free. So I set it up so maybe I can generate some cash with the primary purpose of hopefully buying a new home. I had the idea where I will work on open source software, open source models, maybe do these tutorials, give out lots of free content and information, and in the hopes that maybe I can get 300,000 people to donate $1. So this way I can buy a new home because I live in a flood zone in Jersey, and I've been hit by both Irene and Sandy. And other than damage to my house and my house losing half of its property value, I kind of want to move out of the flood zone because we were, long story short, I was there during Irene, and me and my family could have lost our lives, and we could have lost everything and our lives or whatever. It was a bonehead move to stay because Irene wasn't that bad. So I don't want to experience that again. We experienced floods 2 years in a row that did some damage, and I don't want to do that again. I kind of want to protect my family. I don't want my son to see that again. So that was really the whole point of Patreon. So since I do so much open source and free stuff, that maybe if I can get enough people to donate, I'll move my family out of the flood zone. But I'm not being dependent on that. I'm saving up little by little. I'm hoping at some point to make a game, and whatever profits I make on the game, maybe that will go toward that. So that's pretty much like my main goal is just move out of the flood zone into inland where my family can be safe from floods. 'Cause trust me, floods are not fun. So anyone who's ever been in a flood, I feel your pain. FEMA sucks, but WebGL rocks. So like I said, I'm not begging for anything. No one has to give me Patreon. It's just if you guys think I deserve $1 just for the stuff I'm giving you, that's fine. I don't want to give you guys a pity story or whatever. So yeah, I just wanted to give you guys. I just really want to say thank you to Michael though, because like I said, you rock. You're the first one to give me $1, and I just want to really say I really appreciate it. Me and my family appreciate it. Even if you're the only Patreon that gives me any cash, that's fine, because I know that one day that we buy a new house out of this flood zone, $1 of it is thanks to you. So thank you, Michael. My family thanks you. Rock on. And I guess see you guys at the next lesson. Like, subscribe. And again, if you guys want anything, any kind of tutorial, tell me. Just like for Jiro G, this is for him. If anyone else wants something, I'll see if I can squeeze it in between some of the ideas I've had. All right. So see you guys in the next lesson. Rock on and stuff. Bye-bye.